This tutorial will be based on lecture 4. You remember I'd given you about 25 homework questions that you're supposed to go through.
So we have our first question there, which is question 4-4, part of the homework that we had. So moment about point A, that's due to various forces. So we've got a force F1, which is equal to 375 pounds. Then you have got F2, which is equal to 500. Then F3 is equal to 160 pounds. Okay? So for us to be able to get the moments about point A, due to these various forces, we need to simply multiply the magnitude of the force multiplied by the perpendicular distance to the force. So in this case, the F1 equal to 375, its perpendicular distance is 8. So once we multiply there, we have 8 by 375, we get 3.0 kilo-pounds feet. So direction here tends to be clockwise, but then our initial assumption was that we are going to take all anti-clockwise moments to be positive. Okay, so because of this, we're able to see that the magnitude of the moment takes up a negative there. Same thing will happen also to the force 2, but once we resolve force 2 into its component, you have got its y and the x, but we find here that its x component will actually pass right through the same point O. So it won't have any impact in terms of the moment. So the only component of F2 that will give us a moment here will only be F2 in the y, which is 500 multiplied by 4 over 5. Okay, so once we multiply, once we get the component there, we're supposed to multiply it by the distance, which is 8 plus 6. That's the perpendicular distance from the point of action of the force F2 up to point A there. So giving us a magnitude of negative 5.6. Then the third moment, that's due to the force F3, will simply be 160 sine 30, which is actually the x component. So that is multiplied by 0.5. And this moment is going to be a positive moment because it has taken the anti-clockwise direction. And then the other one, that's the other moment that's due to the force in the y direction, takes up a negative, which is 160 equals 30. And then you add 8, 6, and 5 to get us the lever arm distance. So this is simply what was required of us as pertaining to question 4-4. You're simply using the formula moment is equal to force times distance. Okay, I hope this solution is clear. So I'm moving to the next question, which is question 4-12. Okay, so this next question, we have a diagram with us here, and then the question is saying we're given the distance x, which is equal to 10 meters. Then it's asking us to determine the angle theta such that the moment about point O will be the maximum moment. So the 6 kilonewton that's applied at point A tends to cause a clockwise moment about point O. So we need to find the magnitude of this moment, considering that it should be the maximum moment. So for us to be able to get the maximum moment about point O of the 6 kilonewton, this will only happen if and only if the 6 kilonewton is acting perpendicular at point A to the distance OA. So if you look at the diagram that we have with us here at the bottom here, the second diagram labeled A. So here we can see that 6 multiplied by 8 gives us a moment of 48, which is a clockwise moment. So this is the maximum moment that we're going to get at point A. And then the next part of the question, okay, so for us to be able to get the angle theta, we have to critically look at this. Clearly shows us that the x there is 10 meters, and then we've got two distances there. That is x prime prime, and then there's another distance x there, x prime. So what we can see from this diagram A is that the 10 meters is going to be equal to this. So